Hey friends, welcome back to my physics class. So today we are going to learn more about vectors. So today's topic is resolution of vectors. Let's first understand what do we mean by resolution of vectors. Like in our last class, we have seen when we are adding or subtracting two vectors, we are getting the resultant of vectors. So now here the process is like backward. Here a vector is given. Here we are going to find out its component. That means the vectors which when added or subtracted will give you this resultant vectors. So now let's understand. This is the vector A, any vector A. So this vector will have a magnitude and have a directions. So here we are going to find out its component in various directions. That means we are breaking this vector into different direction. We are breaking it into its component. So it can be two-dimensional, three-dimensional. So here we are considering only the two-dimensional. That means we are going to find out the components along the two orthogonal x-axis and y-axis. Now let's represent this vector A from this Cartesian coordinates. It makes an angle theta along positive x-axis. Now from its length, let's say this is the length. Similar to this vector A. Now from its tip, from here, we are drawing a perpendicular on the x-axis. Now this gives us a right triangles. So this is basically the basic trigonometry. So if we'll try to find out from this right triangle, the cosine of the angle theta, we can see that this is the base upon the hypotenuse. So this is AX, like the X component of the vector A, then the magnitude of the vector A. Let's say this is A. So from this we can find out the X component of the vector A. So that is the magnitude of A times the cosine of the angle given, or the vectors mixed with the x-axis. Now again from the triangle OAB, the right triangle OAB, we can find out the sine theta, and the sine theta will be the perpendicular upon the hypotenuse. And what is this AB? This is this perpendicular. This is the y component of the vector A. This is the y component of the vector A, and this is equals to this side AB. So we can say that AB is AY, that is the y component of the vector A, upon the hypotenuse OA, that is same as the magnitude of the vector A. Let's say this is A. So from here, we can simply say that the AY, that is the y component of the vector A, is nothing but the magnitude of the A times the sine of the angle made by the vector A. So this is the standard form. The horizontal component of any vector that makes an angle theta, or any angle with the positive x-axis, the horizontal component is going to be the magnitude of the given vector with the cosine of the angle made by the vector with the positive x-axis. And the perpendicular component, that is the y component of the vector A, will be the magnitude of the A times the sine of the angle made by the vector with the positive a-axis. Now this is the standard form, but there are various ways you can find out the resultant resolution, or the resolution of a vectors. That is its component, it in various direction. You can either apply the basic trigonometry or the standard form. Let's take an example here. Now let's say this is a block which is acted upon by the force of 10 newtons. So if it is acting in this direction, so which direction it will move? Let's say it will move in this directions. Now, let's think. This is not here. If this force is acting, though this block will move in this direction. And if this force is applied, then the block will move along the upward direction, let's say the north direction. Now think analytically, what will happen if simultaneously we apply the force, this one and this one? Then what will be the resultant? The resultant is like the result vector will pull this block along this direction. That means we can say that this force is same as acting two forces, one along x direction and one along y direction, to produce the same effect, the same result. So now I hope you understand a vector can be obtained by breaking into different directions when it makes an angle with certain directions. Here we always consider that the vector makes certain angle from the positive x-axis. Now the first question is, this is one example. The first question is, the force is acting, the force on the block is, let's say, 10 Newton, and that force is making an angle 40 degree with the positive x-axis. Now let's find out its horizontal component and its vertical components. Now from the standard form, the Fx will be how much? The x component is the magnitude of the F, that is 10 Newton, and the cosine of the angle made by it, that is cos 40 degrees. So when you solve, you will get somewhere 7.66 Newton. Now what is the Fy, that is the y component of the force? It will be F, that is the magnitude of F, which is 10 Newton, and the sine of the angle made by the force. Then if you solve this, we will get 642. Now let's think, if instead of this 40, the angle, the reference angle is given as 50 degree, like this. So here you can apply two methods. Either you can say that this 50 degree is same as the force is making 40 degree with the positive x-axis, and then you can find out Fx as 7.66 and Fy as 642. These two questions are same, but here the reference angle is 40 degree, here the reference angle is 50 degree. So for this type of questions, you can either consider this as 40 and go for this method, or you can simply draw perpendicular from the tip to here and use the basic geometry and find out its x component and y component. The only difference is that here the x component of the force will be F sine of the 50 degree, and that will give you exactly the same result. See here, Fx is equals to 7.66. Here, Fx is equals to 7.66. Here, you multiply cosine of 40, which is same as sine of 50. Or you can use the standard notation, that is the horizontal component is the magnitude of vector multiplied with the cosine of the angle made by the vector with the positive x-axis. This is the standard notation. When we measure any angle, we take the angle from the positive x-axis in counterclockwise direction. Same way you can find out the y component of the vector. Then in this way, if you take, this will be the y component will be the f time, that is the magnitude of f time the cosine of this 50 degree. Or if you're taking this 40, you can simply write f sine 40. Okay, I hope you got it right. Now I have a challenging question for you. This question is for you to solve. Now let's say this is a force which have a magnitude of 200 Newton, and that acts at an angle of 210 degree